and welcome to this video, which is for the second part of the review in the first workbook for the class Discovering Exponents and Polynomials, which is offered at outschool.com. If you're not a part of this class but want to learn more about this, check out in the description a link to the class on that website. If you're in this class, please check your paper right now. Okay, you should have already done the review. Go ahead and pause this, check your answers, and then come back and we'll talk about it, okay? All right, so I'm going to assume that you're done checking, and we're going to talk about this. So a radical, this is the radical symbol, okay? And what's underneath is our argument, and we got to find the base, okay? So it's like we're working exponents backwards, which is exactly what we're doing, because this is an opposite operation. Now remember, in exponents, if it was 4 squared, it was 4 multiplied twice. So whatever goes here and here needs to be the same number, okay? And we should know from our math facts at this point in our math career that that is 5. All right, so most of these, and I'm going to skip the ones that might be harder, but most of these, we should know the math facts that equal these numbers. I know that 9 times 9 equals 81. I know that 3 times 3 equals 9. Now, when you take the answer, you only take half of the process, okay? You just want the base, not the exponent. The exponent tells me how many times to do it. So if I had written this like an exponential form, it would have been 5 squared. Well, the answer, okay, to a radical is just the base, not the exponent. So just that 5. Okay, for this one, it would just be this 3, just be this 9. Let's skip over 4 for now. 1 times 1, okay, would equal 1. So I just take one of the process. I just take the base part of the process. Okay, this one I'm going to keep for a minute. This one we should know that 7 times 7 equals 49, so I'm just going to keep the base. This one I'm going to skip. 0 times 0 is the only thing that will equal 0. I mean, 7 times 0 will, but I need something where the number is both the same, and the only way to do that is 0. All right, I'm going to keep that one for a minute. 2 times 2 is the only way to equal 4, so I take one part of it, the base, and the answer is 2. Here we should know that 4 times 4 equals 16, but I just want the base, which is one of them. All right, so the answer is 4. 6 times 6 equals the 36, but I just want the base, which is just one of the factors in the multiplication problem. 8 times 8 equals 64, but I just need one of those factors. And we're going to save 11 and 16 for a minute. All right, if you get stuck on one, a way that you can do it, even though these are ones you should have memorized, I can break it down into its factors, okay? I can make a factor tree. So I know 10 goes into this because it ends in a 0, okay? So then 10 times 10. Look, I have 2 of the same factors. I'm done. Now I could have went a different direction. I could have said, well, I know it's even, so 2 can go into it. 2 times 50. Okay, now I know 5 can go into this. 5 times 10. All right, and then I know that 10 can break it down to 2 times 5. So when I'm done, my prime factors are these. And I see that the 2 and the 5 repeat just like the 2 and the 5 are right here. They repeat. So I know those must be my perfect square, okay? So 2 times 5 is 10. 2 times 5 is 10. I know that 10 times 10 equals 100. So the factor, just taking one of the factors to be the base, would be 10. The answer is 10. All right, I could say that this is, I know it's even, so I'm going to say 2 goes into it. And 2 goes into it 72 times. 72, I know that's 9, right? So 9 times 8 is 72. All right, break down my 9, and that's 3 times 3. 8 is 2 times 4, and 4 is 2 times 2. So this one I have a 2, I have a 3, I have a 2, I have a 3, I have a 2, and I have a 2. Okay, so I have 4 2's and a 3. All right, so I know that I need 2 2's and a 3. And then over here I need a 3 and 2 2's. I have to have the same amount of each factor. So 2 times 3 is 6 times 2 more is 12. 3 times 2 is 6 plus 2 more is also 12. So I know it's 12 times 12, one of them being the base, which is the answer of 12. 255, I know that's divisible by 5. So let's break it down. 5 goes into that 4, and then with a leftover 2, drop down my 5, 45 times. If I break down this 45, that's 5 times 9, and 9 breaks down to 3 times 3. So 5 times 5 times 3 times 3. So I know I have to have the same. 1 5 for this one, 1 5 for this factor, 1 3 for this factor, 1 3 for this factor. So 5 times 3 is 15. 5 times 3 is 15. So 1 for the base, the answer would be 15. 196. I know that number, it's going to be a long one, so I'm going to write it up higher. I know that's even, so I'm going to say it's divisible by 2, which is going to make it 98. Break down 98 again, it's even. 2 can go into that 49 times. All right, and I know that 49, the only thing is 7 times 7. So I have a 2, a 2, a 7, and a 7. So I got to take 1 for both. So 2 times 2, and 2 times 7 and 2 times 7, which is 14 times 14. I only need 1 as the base, so the answer is 14. All right. So this one, the only factors it has is 11 times 11. They're both prime, okay? So you're just going to have to memorize that one if you can't look at it and see that it's 11 times 11. These all, you should be able to, they should come right off your tongue. All right? If I look at this, oh, this one's hard. This one is 2 primes again. So you just have to remember that it's 13 times 13, or use the backwards trick of that I showed you in the exponents one. All right, so I hope that helped you figure out how to do these radicals. Keep studying them. Again, this is a skill that needs to be memorized, and then come back and we'll do some more.